What is quantum computing? Quantum computing is a place of look at the improvement of PC, primarily based totally technology targeted across the concepts of quantum concept. Quantum concept explains the character and conduct of power and can be counted at the quantum atomic and subatomic level. Quantum computing makes use of an aggregate of bits to carry out particular computational obligations, all at a miles better performance than their classical counterparts. Development of quantum computer systems mark a bounce ahead in computing capability, with large, overall performance profits for particular use cases. For instance, quantum computing excels at simulations. The quantum PC profits plenty of its processing energy via the capacity for bits to be in a couple of states. At one time they can carry out obligations, the use of an aggregate of 1 zeros, and each a 1 and 0 simultaneously. Current studies, facilities in quantum computing consist of MIT, IBM, Oxford University and the Los Alamos National Laboratory. In addition, builders have started getting access to quantum computer systems via cloud services. Quantum computing started out with locating its vital elements. In 1981, Paul Benioff at Argonne National Labs got here with the concept of a PC that operated with quantum mechanical concepts. It is normally general that David Deutsch of Oxford University supplied the essential concept at the back of quantum computing studies in 1984. He started out to surprise approximately the opportunity of designing a PC that turned into primarily based totally solely on quantum rules, publishing a step-forward paper. Some months later, quantum theory's improvement, started in 1900 with a presentation with the aid of using Max Planck. The presentation turned into the German Physical Society, wherein Planck delivered the concept that electricity and relay exists in person units. Further trends, with the aid of some scientists over the subsequent 30 years, brought about the cutting-edge expertise of quantum theory. The essential elements of quantum theory, energy, like matter, includes discrete units in preference to a non-stop wave. Elementary debris of power and matter relying on the conditions may also behave like debris or waves. The motion of standard debris is inherently random and thus unpredictable. The simultaneous eyes of complementary values, which includes the placement and momentum of a particle, is mistaken. The extra exactly one price is measured. The extra mistake, the size of the alternative price, will be further developments of quantum theory. Niels Bohr proposed the Copenhagen interpretation of the quantum idea. This idea asserts that a particle is something it's far measured to be, however, that it can't be assumed to have particular properties, or maybe to exist till it's far measured. This pertains to a precept referred to as superposition claims. Whilst we no longer understand what the nation of a given item is, it's far simply in all feasible states simultaneously. So long as we do not appear to check to illustrate this idea, we are able to use the well-known analogy of Schrodinger's cat. First we've got a resident cat and located it in a lead field. At this stage, there's no doubt that the cat is alive, then throw in a vial of cyanide and seal the field. We no longer understand if the cat is alive or if it has damaged the cyanide pill and died. Since we now no longer understand the cat is each alive and dead in line with quantum law in a superposition of states, it is best, whilst we spoil the field and spot what situation the cat is in, that the superposition is lost and the cat should be both alive or dead. The precept that in a few ways one particle can exist in several states opens up profound implications for computing. A comparison of classical and quantum computing. Classical computing is based on ideas expressed through Boolean algebra, normally operating with a 3 or 7 mode. Good judgment gate principle. Data needs to be processed in an extraordinary binary country at any factor in time, both 0 or false, or 1 untrue. These values are binary, digits or bits. The tens of thousands and thousands of transistors and capacitors on the coronary heart of computer systems can most effectively be in a single country at any factor. In addition, there's, nevertheless, a restriction as to how fast those gadgets may be made to exchange states as we develop to smaller and quicker circuits. We start to attain the bodily limits of substances and the brink for classical legal guidelines of physics. To apply, the quantum laptop operates with a mode good judgment, gate XOR, and a method referred to as Q01. The cap potential to alternate 0 right into a superposition of 0 and 1 in a quantum laptop. Some elemental debris, including electrons or photons, may be used. Each particle is given a charge or polarization performing as an illustration of 0, and a 1. Each particle is referred to as a quantum bit or qubit. The nature and conduct of those debris shape the idea of quantum computing and quantum supremacy. The maximum applicable elements of quantum physics are the ideas of superposition and entanglement superposition. Think of a qubit as an electron in a magnetic field. The electron spin can be both in alignment with the field. That's called a spin-up kingdom or contrary to the field. That's called a spin-down kingdom. Changing the electron spin from one kingdom to some other is performed with the aid of the use of a pulse of strength together with from a laser. If the best half of a unit of laser strength is used, and the particle is removed from all outside influences, the particle then enters a superposition of states behaving as though it has been in each state simultaneously. Each qubit applied may want to take a superposition of each 0 and 1, meaning the quantity of computations. A quantum laptop may want to take as 2n, in which n is the quantity of qubits used. A quantum laptop composed of 500 qubits could have a capacity to do 500 calculations in an unmarried step. For reference, 500 is infinitely more atoms than there are within inside the regarded universe. These debris all engage with each other through quantum entanglement, in contrast to classical quantum computing counts as actual parallel processing classical computer systems. These days, nevertheless best in reality, do one element at a time in classical computing. There are simple, or extra processors to represent parallel processing. Entanglement particles like qubits, which have interacted sooner or later, preserve a kind, may be entangled with every different pair in a manner called correlation. Knowing the spin nation of one entangled particle up or down offers away the spin of the alternative with inside the contrary course. In addition, because of the superposition, the measured particle has no unmarried spin course earlier than being measured. The spin nation of the particle being measured is decided on the time of size and communicated to the correlated particle, which concurrently assumes the alternative spin course. The purpose in the back of why isn't explained. Quantum entanglement permits qubits, which are separated by means of huge distances, to have interaction with every different instantaneously. Now, no longer constrained to the rate of light no count number, how remarkable the space among the correlated particles. They may continue to be entangled, so long as they may be isolated, taken together. Quantum superposition and entanglement create a rather improved computing power, where a 2-bit check-in in a regular laptop can keep most effectively, certainly considered one among 4 binary configurations, 0, 0, 0 to 1, 10, or 11 at any given time. A 2-qubit check-in, and a quantum laptop can keep all 4 numbers concurrently. This is due to the fact every qubit represents values. If greater qubits are added, the extended capability is improved exponentially. Quantum programming. Quantum computing gives a capacity to write down applications in a very new way. For example, a quantum PC may want to include a programming collection that could be alongside the traces of take all of the superpositions of all of the previous computations. This might allow extraordinarily rapid methods of fixing positive mathematical problems, which include factorization of huge numbers. The first quantum computing application appeared in 1994 via the means of Peter Shor, who advanced a quantum set of rules that might correctly factorize huge numbers, the problems and some solutions. The blessings of quantum computing are promising, however, there are big boundaries to overcome. Some issues with quantum computing are interference. The slightest disturbance in a quantum device can reason a quantum computation to collapse. A method called decoherence, a quantum laptop, has to be completely removed from all outside interference for the duration of the computation phase. Some fulfillment has been performed with the usage of qubits in extreme magnetic fields. The usage of ions output, observance, retrieving output, facts after a quantum calculation is whole dangers corrupting the facts. Developments have been made consisting of a database set of rules that is based at the special waveform of the opportunity curve in quantum computers. This guarantees that, after all calculations are done, the active size will see the quantum nation to cohere into the appropriate answer. There are many issues to overcome, consisting of the way to take care of safety in quantum cryptography. Long-time quantum statistics garage has been a hassle with inside the Beyond 2. However, breakthroughs with inside the final 15 years and with inside the latest Beyond have made a few shapes of quantum computing practical. There continues to be plenty of debate as to whether or not that is much less than a decade away or 100 years into the future. However, the cap potential that this generation gives is attracting brilliant hobbies from both the authorities and the personal sector. So after all, we have come to the end of this video. Write down in comments which one is your favorite and share with your friends and family, and don't forget to subscribe. So see you all in the next video. Till stay tuned.